Okay, so we're going to have a tutorial on the IceBlaster controller, the DCAS4. It's an ambient sensing controller based on a digital thermostat controller that measures outside temperature with a thermistor probe. One of the things you'll notice, first of all, about the DCAS4 is all of the controls are on the outside of the panel. And that keeps you safe. That keeps you away from all of the high voltage that's inside. You'll see competitor panels, imitators of this, but they have everything on the inside of the panel. Requires you to open it up. You're right in by all the high voltage wire, and you got, could be up to 4 circuits, 240 volts on each circuit. You just shouldn't be inside the panel. It's not a safe situation. In fact, one of the competitor panels, they don't even have a UL listing on their panel. We have a full UL listing. It's an industrial UL listing, so it meets very high standards. They're manufactured in our UL 508A panel shop to very exacting standards. So as we look at our panel, you notice all of the things on the outside. It's very easy to operate, very easy to get the feedback to know what's going on. So as we look at this, it's got a 3-position rotary selector switch. The first position on it is a manual. And so when you turn it to manual, nothing's going to light up on our control panel because all it's doing is kind of flipping a switch on the inside of the panel. It's closing a contactor so that all of the incoming power can thus flow to the heat cables themselves. So in effect, turns the heat cables on. It's just like a very powerful on-off switch, and so it can be managed that way. It can be used that way under some circumstances. It can be a good idea. Certain situations where you don't want it under full auto mode, where you just want to turn things on for a short while to take care of perhaps a single event. But what's most exciting about the DCAS4 here, the IceBlaster Digital Control panel, is when it's in auto. Now, our panel allows for what we like to refer to as window operation, so that when the outside temperature is between about 35 and 5 degrees, it's going to have the heat cables turned on. That's the temperature at generally which snow melts, either through heat loss from the house or solar gain from the sun. Even though it might be 15, 20, 25 degrees outside, those things can melt snow. That snow runs down to the bottoms of valleys, gutters, roof edges, all those areas, and it encounters much colder air because now it's exposed. It can refreeze there. And that's how ice dams start, with those repeated cycles. So this controller is designed to have the heat cables on in that window. So if it's above 35, 36 degrees or below 5 degrees, the heat cables don't need to be on. Now, perhaps your situation at your home, those parameters aren't exactly right. We have the opportunity to adjust those settings. So the first setting is under Out 1. You'll see the little dot there under Out 1, and that allows you to arrow up and arrow down so that you can fine-tune it. And then the next button, hit set again, and that'll bring it over to Out 2. It's flashing, so you can see you can arrow up and arrow down with that. Now we've just got these set for the temperature range that we're in now, so we can see things working. So now if we look at it, we've got that set point up above the ambient temperature, and so you see the light on, it's reading temperature. The light is on under Out 1. That means it's closed the switch, the contactor that's inside of there, and it's allowing power to go to the heat cables. So it's energized in effect. When the dot would appear under Out 2, let's say that temperature fell below that second point that we set, let's say the temperature fell below 62, then we would see an additional dot under Out 2 indicating it was below that low temp cutout. Once it rose back above those parameters, then it's in that window. It would the dot would disappear here, and it would tell you that the system is running. Now, don't get confused by the lower dot. That's just a decimal point, so it's a very accurate temperature measurement. Now, let's say you're having a little problem with the calibration. Perhaps where you've set the thermistor, maybe it's the house is emitting a little bit of heat, and maybe actual temperature, this is reading maybe 5 degrees warmer than what it actually is outside. Well, we've got the ability to set that calibration, or to calibrate the controller here. And that's done, I've held it down about 8 seconds, hit set again, and then we can arrow up to the setting. And the calibration setting, we want it on probe 1, calibrate. If it's reading high, we would dial down. If it's reading high 2 degrees, we'd calibrate it and go to that point. And then that would readjust the reading that it's taking. So we're going to just leave it at 0 for the time being. And then to get it back to that, you hit the set and the arrow key. So it can calibrate, which is a really nice feature, because sometimes when you put these probes, it's not reading what actual ambient temperature is. And we want these things to be fairly close measuring temperature, so that we don't have to have them set excessively high and excessively low. That uses more energy. So a real nice feature about our controller. It's something that you don't find in a lot of other controllers, the kind of flexibility that we have, especially with this thermostat controller here. This is an industrial type thermostat controller, so what you're getting is an incredibly accurate, incredibly versatile controller, one that's going to last a long time. So that's kind of the tutorial on our product. It's got the great ability to adjust the temperature just depending on your circumstances, both the upper and the lower. When they come right from the factory, we're going to have them set for you at 37 degrees and 9 degrees. And we found in our experience with these systems, that's kind of a really good window to be at. You don't want to be down right next to freezing, because what can happen is, as ambient temperature warms, the outside temperature warms, might have been 15 degrees at night, all of a sudden it gets to be 38 during the day. Well, it's warming up, it's going to turn the controller off because of the sensitivity of that probe, but the gutters may still be at 20, 25 degrees, so that meltwater is going to start refreezing in the gutter if this system isn't on. So that's why we have them set a little higher. It also catches perhaps the snowfalls that might happen at 35, 36 degrees. We get sometimes those types of snow events as well. So the factory settings are really good, but if they aren't working out for you, there's the flexibility to adjust that to meet your needs. So that's our DCAS4, handles up to 4 separate circuits, 240 volt max at 30 amps each circuit. So that's quite a large system that it can operate with just one panel, eliminating the need to have multiple thermostat controllers. We also have a companion to this, an 8-circuit controller that has 2 switches or 2 contactors in it. They each can handle up to 4 separate circuits, but one of the contactors is delayed by 2 minutes for its startup. And what that affords is you don't get the massive inrush when you kind of split the circuits up that way and have that delay built in. So that's kind of a big help, especially on residential homes where these panels are very popular as well. So thank you for considering this. Hope this has been helpful. A nice tutorial on our product. If you have any questions, you can visit us at VersaScreenGutterProtection.com. Again, that's VersaScreenGutterProtection.com for the IceBlaster DCAS4 Controller. Thank you very much.